Hello, I'm Svetlin Nakov from the Software University, SoftUni. I'm your Java programming instructor. I'm here for the next part of my free Java Basics coding tutorial where I teach the basics of programming through a series of video lessons with hands-on coding exercises with the Java programming language. In case you have missed the previous part of this tutorial, please review them to catch up because this lesson is a continuation of the previous lesson, which were about conditional statements. In this lesson, I will talk about advanced conditional statements and how to implement complex control flow logic in your Java code. I will demonstrate how to use nested conditional statements, an if-else, which states inside another if-else, and how to use logical operators such as AND, OR, and NOT to build more complex conditions in your conditional statements. I will explain the switch case statement, which is used to make series of checks, and the multi-label switch case statements, and how they help when we check a series of values for the same input. Using all these techniques, we will write complex program logic that corresponds to complex real-world scenarios we can see in our daily lives. As usually, I will finish this lesson with several practical coding problems, which you should solve to gain hands-on experience with writing advanced if-else statements and series of checks. As usually, once you have written the solution for some of the exercises, your code, you will be able to submit it in the judge system for automatic grading and you'll learn whether it's correct or not. This will give you immediate feedback about your code solution. Don't skip the coding exercises. They give you experience and develop your practical skills, which are most important. To learn coding, you should code. That's it. Write code every day and sooner or later you will become a software developer. Just keep coding. And the exercises in this lesson and in the other lessons from my series are a great way to train your practical coding skills. Now it's time to start with the lesson. In the marketplace, we have different prices for certain products based on the day of week. So in the weekend, banana are sold by 2.50 and in the weekend they are more expensive, 2.70. Apples are 1.30 in the weekend, in the weekday, and in the weekend they are 1.60. And it's similar for other products and depending on the weekday and weekend. So we want to calculate the price for certain product and date, and this might be expressed with if-else statements. But how to do this? It would be something like this. Read the input. What is the product and what is the day of week. So if the product is banana, we have two cases. If it is weekday, the price should be 2.50. Otherwise, the price will be 2.70. If the product is apple, again we have two cases. If it is a weekday, the price is 1.30. Otherwise, the price is 1.60. And again, if the product is kiwi, we have two cases. If it is weekday, the price is 2.20. Otherwise, the point is 3.00. So this is a pseudo code which explains that sometimes we need a nested if statements. So this is an if statement, but this is another if statement which happens if the first is true. It's called nested or inner if statement. This if statement happens only if the first is true. So this is how we can express more complex programming logic. Let's see how this happens in programming with Java. So with the nested conditions, we may have if-else inside another if-else. How to do this? An if-else statement can be nested within another if-else statement like it's shown below. We have if expression and we have a block. Or we may have just a single statement later. In the block we have if some nested expression, do something, otherwise do something else. So if this is true and in the same time this is also true, this code will be executed. If this is true but this is not true, this code will be executed. So we have more flexibility if we nest if-else statements inside other if-else statements. So only if the first condition is true, the nested check will be executed, it will be evaluated, and if it is true, some code will be executed, otherwise this other code will be executed. So the final code is executed when the nested expression is false and the first outer expression is true. So we can nest this in such a way at several levels. So we can have if, in it we can have another if-else, inside it we can have another if-else, but it's considered that up to 3 nested levels are okay. Otherwise the code becomes more unreadable and complex to be understood. So please avoid deep nesting. How to avoid deep nesting? Usually we use methods. We will learn how to use methods later, but this is the way we can avoid it. Just extract a piece of code in another method and give a meaningful name. I'll show you this later in some of the next lessons. So let's solve one real world problem, our marketplace. We want to read the product and day from the console, and we want to print the price formatted to the second digits after the decimal point based on this price table. So banana in the weekday costs 2.50. Banana in the weekend costs 2.17. So we need to check the product and after that check the weekday, and with nested statements we can calculate the price. So if the input is the first one holds banana, the second holds weekend, it should be, the output should be 2.17. If the product is kiwi and the week entity is weekday, this is the price, 2.2. So this is our problem, and I'll solve it. But first we have conditional statements Java. This is the previous lesson. So I'll create a new project which will hold the exercises from my current lesson, which will be called Conditional Statements Advanced. Conditional statements with A statements advanced. Now it's correct. The base package should be empty. This will simplify our job, and I will open this in the current window. So the project, I have the same thing in C#. So I need to change the name. Sorry, I just opened a folder which already had some existing projects. So I'll create a new project with different name, which will be called Conditional Statements Advanced Java. Okay, I believe this is correct name, which is unique. And okay, this is the name, and these are the files inside the files. Okay, in src I have main, and I'll create a new class. So I created a project which will hold all my examples and homeworks for this topic, for this lesson, Conditional Statements Advanced with Java. And the first problem is called Marketplace. Marketplace with capital, because this is a class name and it should be with capital, and each word will be capital. For example, if it is coffee shop, it should be coffee shop. Each word with capital letter. This is the standard naming convention in Java. I create the main method, and I want to read the product and the day of week. So I'll declare a scanner, control space scanner equals to new scanner of system.in. Okay, I have the scanner, so I can read the product. So var product equals to scanner dot next line, and again I can read the day of week. Okay, so I'm ready with the input. I can check the product. If the product is banana, but this is incorrect in Java with equal, so I should put dot equals in brackets banana. I'll do something. Otherwise, I can check the product. I'll take this Control-C, Control-V, and this I will delete it. If the product, Shift Tab here, if the product is apple, I'll do something else. Otherwise, it's better to do like this. I have one bracket, which is not needed. If it is kiwi, I'll do something else. Otherwise, I will print invalid or unknown product. The program does not know this product. So if it is banana, I can have another check. If day of week, day without s, day of week is weekday, I'll print the price, which will be 2.70. I'll print it as a string because otherwise, if I print it just as a number, I will need to format it with two letters, with 2 digits after decimal point. I want to move my wife, make my life easier, so I'll do something like this. It's 2.7, 2.50 in the weekday, banana in the weekday is 2.50, otherwise in the weekend is 2.70. Okay, so the similar logic matches the apple. Apples in the weekday cost how much? 1.30, and otherwise 1.60 in the weekend. Okay, and here I'll need, for the kiwi I have 2.2, 2.20 and 3.00, 3.00. Let's try. So I want to buy apple in the weekend. Apple in the weekend, 1.60. Okay, what's next? I can try kiwi in the weekday. Okay, it's 2.2. I can try banana in the weekend. It's 2.70. So this is how it works. I have if which holds other if which holds other if. So I can just I can split this, but it's very ugly. No, this will not work well. But generally, I have if, it holds if. I have else if, it holds another if. I have else if, it holds another if. Here, I may have like this, a block, and I may have other if something, print this, otherwise print this. So this is how I can have deeper nesting. Okay. Okay, so this is how marketplace could be solved, and this is what the solution I had in mind before the start of my lesson. If the day of week is weekday, for banana is 2.50, otherwise 2.70. If the product is apple, for weekday I have one price, otherwise if it's not weekday I have another price. I do the same for kiwi, etc, etc, etc. So the biggest number of 3, this is our next problem. It's about writing a program that reads 3 numbers from the console and prints the biggest of them. Wow, it's a little bit more complex. So if I have 1 to 3, 3 is biggest. If I have -1, -5, -9, -1 is the biggest, obviously. If I have 1, 5, 3, 5 is biggest. If I have 0.5, 1.5, -3, 1.5 is the biggest. So how to solve this problem? Okay, I'll create a new Java class which will be called biggest number of 3 numbers. This name is good enough because it says what inside. Biggest of some 3 numbers. Okay, here I'll take this line of code because I don't want to write it again. I'll write main, we'll import Java to scanner, and I'll say something like double num1 equals to scanner dot next double, and I'll have num1, num2, num3, and I'll check if num1 is bigger than num2. This means that num2 is not the biggest, right? So this says nothing. I'll need another if. If in the same time num2 is bigger than num3, what this says? This says that the num1 is the biggest. Do you agree? Num1, for example, 10, is bigger than num2, for example, 5. But num2 is bigger than num3, for example, 2. So which is the biggest? Num1. Okay? But this is just one of the case. Otherwise, what we have here? Otherwise, num3 here, num3 is bigger or equal than num2. And in the same time, num1 is bigger or equal than num2. We can say nothing. We need another if here because it's not clear which one is bigger. It might be either num3 or either num1. So this is not good. Okay, what about this logic? If num1 is bigger than num2 and num1 is bigger than num3, this num1 is bigger by both num2 or 3. So it's the biggest. For example, this is 10, this is 7, this is 5. And otherwise, what will happen? Because num1 is bigger than num2, and in the same time, num1, num3 is bigger or equal to num1, which is bigger than num2. What happens here? Num3 is the biggest. Do you agree? Let's give an example. Num1, for example, 10, is bigger by num2, for example 5. And num1 is not bigger than num3. For example, this is 12 because this is 10. So which is the biggest? The num3, because num3 is bigger or equal than num1, because it's else. The opposite of this is this. This is the opposite here. So if this happens and in the same time this happens, it's obvious that the num3 is the biggest. Do you agree? I believe it's correct. But here, else, what we have here, if we go at the else, this means that this is not true. This means that num1, num2 is bigger or equal than num1. So if in the same time num2 is bigger or than num3, what happens? Num2 is, for example, 10, is bigger or equal than num1, for example, 5. And in the same time, this 10 is bigger than num3, for example, 3. Which is the biggest? Num2. So here, I will print num2. Otherwise, what happens? Num3 is bigger or equal to num2, and in the same time we have this. Both are correct. So this means this. Okay? It's the same. So which one is the biggest? Num3. Okay? Do you agree? I believe so. And this should work correctly. Let me check whether it's correct or not. Oh, go away. I'll try 10, 20, 30. 30 is the biggest. I agree. 30, 20, 10. 30 is the biggest. And 20, 10. 20, 30, 10. 30 is the biggest. So I had the first, the second, and the third. So if I have 1, 2, 3, the last. If I have 1, 3, 2, it's the middle. And if I have 3 to 1, it's the first. I covered all the cases, in fact. And maybe I should type 5, 5, 5, but it's 5. I should try negatives, minus 1.5, 0.5, minus 15. 0.5 is the biggest. Looks like it works correctly. So this was a little bit more complex logic. Yes, it is more complex logic because we still didn't have learned about the AND operator. Because if this is true, this would be more easier to read. Do you agree? If num1 is bigger or equal to num2, which is bigger or equal to num3, then it is num1. How to write this? It should be like this. And this is the first case. My second case might be this. Num2 is bigger than num1 and num2 is bigger than num3. Oh, this is the case. Num1 is bigger by both num2 or 3. So it's the biggest. Num2 is bigger by both num1 and num3. So it's num2. And the third case is that num3 is bigger by both of them. This is the second solution, and this will work also well, but we didn't have already learned how to use this AND operator. I'll talk about it a little bit later. So let's go back with our nested if statements based solution. This is a solution based on nested statements. This one, and it's completely correct. Okay, so the solution I had in mind before the start of this lesson is check whether the first is biggest by the second. If the first is in the same time biggest by the third, it's true that first is bigger by both second and third. Otherwise, the third is bigger than first, and which is bigger than the second, so the third is the biggest. Otherwise, we have that the second is bigger than the first, because it's the opposite of this. And in the same time, I have second bigger than the third, so second is bigger than both first or third, or equal, but this doesn't matter. And otherwise, the third is bigger than the second, because this is not true. And in the same time, the second is bigger than the first, because this is not true. So third is the biggest. This is exactly the solution I had, but I didn't name my variables num1, num2, num3, but first, second, third. It's the same solution. Okay, let's go ahead and try to solve this yourself, because it's a little bit more complex logic than the things we already mentioned in our previous lessons. So in programming, we often have some non-trivial things that we should just be smart and think of and invent them. So this is called algorithmic thinking, to come up with a correct idea to solve certain problem. Okay, let's go ahead with the so-called logical operators. This, not, and, or operators which allow us to build more complex conditional statements, more complex conditional statement logic, to check more complex conditions. Sometimes we often use logical conditions. Things like check whether the minutes are less than 60, or check if the price is bigger than 1.50. This is called a logical check or logical condition. But this is a simple logical condition. Just value, operator, another value. Value, well, comparison operator, another value. But what will happen if you want to check several conditions in the same time? Check whether the minutes are less than 60, and in the same time, the price is bigger than 150. Or if the first is bigger by the second, and in the same time, the first is bigger than the third. This is an example of more complex logical operators. So the logical operators in Java combine several conditions. They can be combined with the AND logic, logical AND, or the double ampersand operator. It says the first condition and the second condition. I'll show you how this works. Logical OR, either the first or the same or both. This is called OR. Let me give you a real world example for AND. If I'm a male, and in the same time, if my age is over 21, I can enter in the certain nightclub alone, for example, if both conditions are in the same time true. Or if I'm over 21 years old, or I come with old person, I can enter in a certain club. To enter in certain club, I should either be old of age more than 21 years, or I should come together with someone which is old. This is OR, logical OR. And not means if I'm not under 21 years, I can drink beer. For example, logical negation. Also, we may have brackets. Brackets change the order of execution. And this is just when we don't know the exact priority. I'll show you how to use the brackets, but they're just like in math. In math, the multiplication has higher order of execution than plus and minus. So we can use brackets to change the order. It's the same applies for Boolean expressions and logical operators. So the logical AND this operator ampersand ampersand double ampersand, it's true when both conditions are true in the same time. So if I'm old enough and if I signed an agreement, I can purchase, for example, a car. I should have 21 years and I should sign some documents. I can purchase a car. Both conditions should be true in the same time. The OR logic is like this. If the first condition is false but the second is true, the OR means one of them, so it will be true. If the first is true and the second is false, the OR condition will be true. So if I'm old or come together with someone who is old, I'm allowed to enter in the club. It is in Java the vertical to vertical lines. This is called OR, logical OR. But the OR works if both conditions are true. If I'm old and I come together with a friend who is also old, I will also be allowed to enter in the club. Okay? And negation means the opposite of something. So if I'm not under 21, if I'm 21, if my age is less than 21, I'm not old, I'm young, okay? But if I'm not under 21, I'm considered old. This is a negation. This is the exclamation mark operator in Java. I'll show you how this works in practice with some code. This is an example of Boolean expression which returns true if all the operands are true. Assume this this problem here. Sorry. I have a point xy, and this point is inside this rectangle if 4 conditions are true in the same time. It is on the right from this x1. It is on the left from this x2. It is on the down from this y1, and it is on the up of this. So if it is on the right from this side, and on the down from this side, and on the left from this side, and on the up from this side, if these 4 conditions are true in the same time, this point is inside this rectangle. Do you agree? Yes, it's true. So if the position x of this point is on the right from x1, the right from here, and in the same time if x is less than x2, which means this is x2, 12, this is 12, left from here, less than x2, and it is bigger than y1, which means this, and it is less than y2, which means this. If all of them are in the same time, this means that it's inside. So this is a very good example how to use AND, logical AND. Another example is to write a program which adds bonus points to given number. So we have achieved some result, and if the result is from 0 to 3, we add 5 bonus points. If the result is from 4 to 6, we add 15 additional bonus points. If the points are between 7 and 9, we add 20 additional bonus points. So this is how this can be implemented. If we have 4 points, we add more 15 and our result is 19. How this can be implemented? Bonus points. We read the bonus points. If the points are from 0 to 3, we add 5. Otherwise, if points are from 4 to 6, which means the points are bigger than or equals to 4, and in the same times bonus points are less than or equal to 6, this means that we have range 4 to 6. This is how we express this in Java. Okay, I will create a class called bonus points, and in the main I'll take this scanner from here, Control Tab, switch to the next editor, to the next file, which is already open. I will read the points. Double points equals to scanner dot next double. And now, if the points are between 0 and 3, between 0, bigger than 0, and points are less than or equal to 3, then I add 5 points. Otherwise, I have something very similar, so I copy this. If they are from 4 to 6, I will add 15 bonus points, right? If they are from 7 to 9, I will add 20 more points. And finally, I'll print the final result. What will happen if I have 4.3 points? 4.3 falls here. So plus 15, I will have 19.3. What will happen if I have 0.7? With more 5, I have 5.7. What if I have 9 points? More 20, I will have 29. What if I have 0 points? I will have 5. What will happen if I have 100 points? I will stay with the same because there is no bonus for this range. This is how the logical AND works. It checks the first condition and second condition and third condition, etc, etc, etc. So this is the solution of the problem I already demonstrated to you. So let's go ahead to discuss the logical OR operator. The logical OR operator is some operator whether the result of the expression is true if one of the operands is true, or both of the operands, or left operand or right operand is true. If one of the members of this OR expression is true, the entire expression result is true. Otherwise, it's false. So if S is tea or S is water, this will be true. I don't need this. If S is tea or S is water. So let's solve this problem. Check for food or drink. Whether something is food or drink. We read a single line and print drink, food, or unknown. We consider that the foods are curry, noodles, sushi, and spaghetti. That's all, only 4 types of food. And drinks are tea, coffee, and water. Okay? So everything else is unknown. How to solve this? This is called food or drink. Okay? I'll copy this, Control C, Control V, food or drink. Okay. And I'll start from this template. I'll have a string with capital S equals to scanner dot next one. S is our input or item, for example. It might be item. If the item is curry, okay, or the item is noodles, I'll copy this, or the item is sushi. I think I don't need this, but what will happen? Oh, it's too long, the line is too long, so it's better to split it, maybe like this. Maybe like this, or the item IntelliJ IDEA wants this to be formatted in certain manner. Yeah, sushi, and finally I should check spaghetti. For spaghetti, if one of this or this or this or this happens, I'll print food. Okay. I'll print this is food. Otherwise, I'll check for this. I'll check for water or tea or coffee, and if one of them happens, I'll need a bracket here closing, I'll say that this is drink. Otherwise, I'll say that this is a noun. Let's check whether this works. So in these 4 cases, I'll print food. In these 3 cases, I'll print drink. In all other cases, I'll print a noun. Let me check whether this works. I have tea, it's drink. Okay, I have water, it's drink. Okay, I have noodles, it's food. I have sushi, it's food. I have a banana, it's a noun, because the program doesn't know this one. So this is the solution, and this is how it works here. It's very similar without the blocks with opening and closing curly brackets, but it's essentially the same solution, just a little bit more less code. Okay, so let's demonstrate the watch go not. The watch go negation or not returns true when the operand is false, and false when the operand is true. So it inverts the value. Here is an example. We want to check for a valid number. By definition, a number is valid if it is in the range from 100 to 200, or in the special case where the value is 0. So valid numbers are 0, 100, 101, 102, etc. until 200. So we have a little bit more complex expression. So is valid, Boolean is valid, is this, num is bigger than 100, and in the same time num is bigger than 200, this thing, or the num is 0. See, we may have here brackets also. But exclamation is valid means invalid. So if the number is not valid, it's invalid, right? So if it's false that the number is valid, this means that the number is invalid. It's the opposite of valid. So this is how this works. I'll say implement this also. Valid number check. For example, it would be something like main. I'll have this, the scanner. I'll take this because I don't want to write it again. Control V with the import. So I'll have a number var num equals to scanner dot next double. Okay, and now boolean valid equals to the following. Num is, let me see, the range from 100 to 200. Num is bigger than or equal to 100, and in the same time num is less than or equal to 200. This means that it is in this range. Or this happens. Num is 0. If one of these cases happens, the value is valid. If the value is not valid, print sorry, invalid value. Okay, I'll run this to show you. 5, it's invalid value. 100, it's valid. 150, it's valid. 200, it's valid. 0 is valid. 201, invalid. 50, invalid. So do you understand the logic? We can have this. So I can use this. I can have if brackets and this. What I wrote here is please check whether the number is between 100 and 200 or it's 0, and use the opposite of this. The opposite of this. And if this happens, say that the value is invalid. For example, 50. It's invalid. But it's better to split this complex condition into two more simple. This is highly more readable. It's much more understandable code. So prefer this code. It's called self-documenting, self-explaining code, because you say it's valid when this or this happens. If not valid, print this. The other complex condition in the if was hard to understand. Okay, let's go ahead with the next section for our lesson. It's called switch case. Switch case is a special operator similar to if-else, which allows checking for multiple values for the same input. So we check something, for example, the age of certain person, and if the age is 5 years, we print something. If the age is 20 years, we print something else. If the age is 10 years, we print something else. This is a way to check the same input for multiple values. This is how this works. It's used for choosing among a list of possibilities. Alternatively to if-else, we have switch, we write switch, and in brackets, we use the selector, which is an expression. For example, age. Switch of age. Okay, I cannot type this. Switch of age. And if the age is, for example, here, 20, do something. Break. Otherwise, check. We may have many cases, many such cases. Default do something. I will demonstrate this. So this is main. I have string day is 5, for example. Int switch of day, and if the day is 1, in case of 1, I will print, in case of 1, I will print Monday, and I will break. It's not like this. You don't have this. It starts with, you always have break and you always have multiple lines. Just the syntax is a little bit strange. Case 2, the second day is Thursday, break, etc. And default, by default, I'll say unknown day. I will need finish the other days. Okay, so what's the idea here? If the day is 2, it's Monday, it's Tuesday. Okay, if the day is 1, it's Monday. If I skip this break here, this doesn't work correctly. Do you see? Because in case of 1, this will happen. But without break, this will continue. So in case of 1, this will go here. So you need to put break after these cases, except the default. Otherwise, it will not work correctly. It's similar to if day is 1, 10, print Monday, else if day is 2, then print Thursday, else print unknown day. So this and this do the same. But here it's more clear that we check the different possibilities for this day. Here we may have more complex and different expressions. So when to use switch? When we have the same expression and we choose for multiple values. Or it's a matter of personal preference. Some people use only if else and never use switch, but switch is sometimes more powerful and more convenient. So this is an example. We print yes or no. We print something. If the value is y, we print yes. If the value is n, we print no. Otherwise, we print invalid response. This is the example. Print yes, no. Yes, no. Main control space. And I'll need this scanner here, control C. So I run this code, I run choice, I press Y, it's yes. I press N, it's no. But if I press Y with small, it doesn't work. It's invalid response. Okay? But what I can do here is to have multiple labels. In case of yes or yes, and in case of no small or no, print no. So this will work slightly better. Okay? yes, it's yes. Y big, it's yes. No, it's no. And N is no. But if I print yes, it's invalid. So I can say that the choice is equals to choice dot to lowercase, and I will need just these two cases, because if I switch the big letters into smaller here by this one, of course, to lowercase. Okay, so if I have Y, it's yes. If I have Y, it's yes. But still, if it is yes, it doesn't work. So I can have that choice is choice dot substring of 0, 1, which means take the from the letter at position 0, 1 letter. Let me check whether this works correctly. Yes, works. Y works. Y works. No! It's no. Now this works better. You can play a lot with this. So this is the scenario to use switch case. We may have switch and many cases, and we may have default, which is something like the final else. We may have multiple labels in the switch case, and I already demonstrated this, because we may have the same action for several values. This is an example: switch selector, case first value, second value, third value, some statements and break. Default, some statements and break. This is an example. Animal. In case of animal is dog or cat or something, it's mammal. Okay? Otherwise, it's a noun. So, in case it's, for example, eagle and pigeon, it's bird. I may have this. For example, species, biological species, main. So scanner equals new scanner of system.in. In this animal, if it is dog, cat, or for example frog, it's mammal. The frog, I'm not sure. For example, horse. The horse is mammal. And in the same time, I may have eagle, pigeon, and some, okay, just these two. It's bird. Otherwise, it's a noun. Switch of animal. Okay. I can rename this animals. Okay. So pigeon, it's bird. Do you know what is pigeon? It's very easy to find this. Just this one. This bird is called pigeon. This is eagle. Do you know it? The eagle. You can check the others. So this is the concept. Let me run it again and try, for example, cat. What's slow? What's slow? It's incredibly slow. But once it runs better. Once it's compiled. So if I use, for example, I don't know, some animal, frog, it's a noun. Okay. So this is the concept of multiple labels inside the switch case. It's really useful. And this was all of the new content I have had in mind for today. So it's your time to solve some problems based on the new skills we learned today. Because learning programming is only possible by coding. Just writing code, solving problems. So it's your time to practice the coding exercises. Please do your best to solve these exercises, which are in the learning system in the homework section. And I will be back in a few minutes to help you and to show you my solutions. So go ahead, I'll be back. Hello again. Now I will help you to solve the problems you had to practice for your practical coding exercises. And I will start from the first problem, which is called fruit or vegetable. It's about writing a program to check for fruit or vegetable. It reads a single line of text. It might be either fruit or vegetable. So we consider that fruits are banana, apple, kiwi, cherry, lemon, and grapes, and vegetables are cucumber, pepper, and carrot, and everything else is a noun. So it just needs to read some input to check whether it is among these fruits or vegetables, and print either fruit or vegetable or a noun. This is an example. If we enter lemon, it should produce fruit. If we enter carrot, we should produce vegetable. If we enter, for example, coffee, it should print a noun. Okay, so let's do this. Fruit or vegetable. I will open the IntelliJ IDEA where I have a project about the conditional statements advanced lesson, and in the source folder I'll create a new class, new Java class, which is called fruit or vegetable. Okay, inside this class I'll have main. I will open some of the previous classes just to copy this line of code, which imports the scanner class. And now I'm ready to read my input. The input will be something like a string item is equals to scanner dot next line. It's an item. So if the item is dot equals, I think we cannot use switch because switch doesn't work for strings. But let's see, if items equal banana per banana, what was the banana, apple, kiwi, cherry, lemon, grapes? Oh, it's a product. Product is a better name. Is the product is banana or the product is apple, then kiwi, then cherry, lemon, copy paste doesn't work well always. Kiwi, cherry, lemon, grapes, cherry, lemon, and finally I should check for grapes. If this happens, I will print that this is fruit. Otherwise, I'll have some other checks like, well, Control V. So I copied this in order to write it faster. It's cucumber, pepper, and carrot. In this case, I print vegetable. Finally, I print noun. This is the entire program, the entire code. I think it's correct, but let's see. I'll start it. Run fruit or vegetable. It's compiling. It still needs some time. So banana. Banana is fruit. Okay, thank you. So lemon. Lemon is fruit. I agree, but what about cucumber? It's vegetable, but what about water? Water is a noun. Okay. Pepper, maybe this should be with double P. Yes, it is with double P. So we are done with this program, and let's see the solution I had in mind before the lesson. It's with switch. Switch like this, and I should check whether this works. I'm not sure that this works because I'm not sure that switch works for strings. We can check in Google. Java switch for string. Okay, switch string in switch in Java. Oh, this works from Java 7. So it looks that it should work, yes. As from Java 7, they have implemented this one. So I can do something like switch of product if this cucumber, pepper, and carrot is a vegetable. Sorry. Control C, Control V. If it is banana, kiwi, lemon, cherry, grapes, banana, kiwi, lemon, cherry, grapes, banana, apple. I have also apple. Then this is fruit. Other white, default. It is, in the default case, it is noun. I don't need break here. It shall work, but I don't need it because here the statement ends the case. Now I run, for example, this program and I enter apple. My first solution says fruit and my second solution says also fruit. If I enter T, both solutions say a noun. So this is the switch case. It looks better, to be honest, than this one. Okay, so this is the solution I had in mind before the start of this lesson, and I have demonstrated you how to use it. Okay, let's go with the next problem, which is called day of week. It's about writing a program to display the day of week as words. So if we are given 2, it should be Tuesday. If we are given 3, it should be Wednesday. So it should read an integer n, which is the day of week in the range from 1 to 7, and prints the name of the days as words in English. It's assumed that the first day in the week is Monday, which is not everywhere in the world, but we assume this like it is in Europe. So prints error if the number is not in the given range. This is an example. 1 means Monday, 9 means error, and 7 means Sunday. Okay, so let's solve this problem. It's called day of week. New Java class, day of week. Okay, Control Tab goes here, and I will copy some of the code from the previous problem, and it would be something like please read the next int in the variable called day, and I will switch of day, and in case of 1 I will print Monday, and I'll take a break. I'll exit from the switch. I should have 1, 2, Tuesday, 3 Wednesday. Looks correct. 4 is Thursday. 5 is Friday. Oh, my favorite day. 6 is Saturday. And 7 is Sunday. And the default is, it should be on the left, is error. Let's run this. So this is the entire code. You can see it, the entire program. We have written 33 lines of code. Wow. So today we wrote a few hundreds lines of code if we combine all the code we wrote together. So if you want to become a developer, you need to have few 100,000 lines of code. Looks good. This means 1,000 days per few hundreds lines of codes, or more intensively. But let's go here. 3 is Wednesday, 0 is error, and 7 is Sunday, and 1 is Monday. Looks correct, so we can go ahead with the next problem. This is the solution I had in mind before the start. It's exactly what I already implemented here. So let's go ahead with the next problem. The next problem is called vowel or consonant. It's about writing a program to check a letter for vowel or consonant. So we read a letter from the English alphabet as input, and we print either vowel or consonant. Or it might be different, but we assume that if it's not vowel, it's consonant. It's unclear what will happen if we enter the dollar sign or space, but we assume the input is correct. So A, E, I are vowels, okay? They can be capitals or small letters, and X, Z, and B are consonant. So this is the problem. We again create a new class which will be called vowel or consonant. Okay, vowel. Okay, looks correct. I'll create my main method, the entrance for this program. I'll copy this scanner from another class I have already written today to save some time. And I will say something like string letter equals to scanner dot next. Do I have next char? I don't have, so I'll take the next one. Then it's good to have letter is equal to letter dot to lowercase. This means that capital letters will be turned to small letters. And now I can say something like switch, and I can say also that letter is letter. No, it's unclear what will happen when we write several letters together. For example, if we enter hello, because we are allowed to enter hello, we might take just the first letter, or the program will not work correctly. But we can say something like, if the letter is we can say like this: input, this is the input, but char letter equals to input dot char at 0 position, which means dot take the first. I don't have the first, but this is the first character. Okay, this is what we can do with strings, because this is string, but generally we can just take char at position 0. So this is the letter, and now the letter is a character. For example, it might be A, or it might be, for example, A, O, it might be also I, U, and what were the other consonant vowels? We can check in internet if we can't remember them. Vowels in English. Okay, so vowel letters are A, E, I, O, U. There are 5. I have forgotten the E. This E. Okay, I'm ready, and I'll print vowel because this is what is required from me with capital letter. Otherwise, I'll print consonant. And that's all. Let's check whether this runs correctly or not. I will enter A, it's vowel. I will enter S, is consonant. I will enter E, capital, vowel, and T, capital, consonant. And if I enter hello, it's consonant. If I enter apple, it's vowel, because it takes just the first letter, only this first letter. Whether this is correct or not, it's a matter of definition. But we can go ahead, and this is what I had in mind before the start of this lesson. I had prepared to take the char at position 0, because if we have a string like, for example, hello, we have this at position 0, this at position 1, etc. So each letter is numbered, which is natural. So we have the letter, and we can check for vowel or consonant, or we can say dot to lowercase like we did here, dot to lowercase, and this to lowercase will allow us to check just these letters instead of all the letters. Okay, and finally, in all other cases, when we don't have a vowel, we consider the input is consonant. Okay, the next problem is called product of 3 numbers. We need to calculate the sign of the product of 3 numbers. Not the product, but the sign. For example, if we have 3 multiplied by -5 multiplied by 2, this is in fact -30. So the sign is negative, right? And if we have 1 multiplied by 2 by 3, it is 6, and it is positive. And if we have 0 multiplied by 4.5 multiplied by 3, it's 0, and the sign is 0. Okay, we enter 3 floating point numbers, and we print positive, negative, or 0. We can do this by multiplying the numbers, or without multiplying the numbers, by considering that if we have odd number of negatives, the result will be negative. If we have one of the product 0, the number will be 0, and otherwise it will be positive. Okay, it's called product of 3 numbers. Okay, new Java class, product of 3 numbers. In this product of 3 numbers, I have the main, Control V. Oh no, I don't have the scanner in the clipboard, but now I have it. I have taken this from the other class, and now I'll read the numbers. Double num1 equals to scanner.next double num1 2 and 3, and I'll do something like this. Double product equals to num1 multiplied by product equals to num1 multiplied by num2 multiplied by num3, and if product is 0, print 0. Otherwise, I'll have as if it is positive, I'll print positive. It is less than 0, I'll print negative. Let me check whether this runs. 3, 4, 5, positive. 30, 0 minus 0.5, it's 0. Minus 0.5, 1.5, 3, it's negative. Minus 1, minus 1, minus 1, it's negative. And minus 1, 3, minus 1 is positive. Looks it works correctly, but this is the solution where we multiply the product. I'll have another solution, which is something like this. We can count the number of negative numbers. So int count of negatives is 0. If num1 is less than 0, then I will increase the count of negatives. Okay. I'll do the same for num2 and for num3. And now I know how many negative numbers I have. If they are odd number, the final product will be negative. But if we have 0, this is a special case. So if num1 is 0 or num2 is 0 or num3 is 0, then this is 0. Otherwise, if the count of negatives is odd number, which means %2 is 1, I'll print negative. I'll have, for example, minus 1, 5, 5. I have one negative number. So if I have 1 or 3 negative numbers, the result will be negative unless it is 0. Okay, and finally, it should be the last case, positive number. Positive. This is our second solution. This is our first solution. I have two separate solutions for the same problem. Okay, let's check whether these both solutions give the same result. 3, 4, 5, it's positive. Okay, I run this. What happens? Minus 2, 4, minus 2, positive. I have 3, 4, minus 2, negative. Minus 2, 3.5, 0, it's 0. Looks like they work, both solutions work correctly, so we are done with this problem. This is the solution I had in mind before the start of this lesson. It was about checking whether we have 0. If we have 0, if one of the input numbers is 0, the final product will be 0. Otherwise, we count the negatives, how many negative numbers we have among the input numbers, and if even, we have positive. Otherwise, we have negative product. That's all about this problem. So let's go ahead with the next problem. The next problem is called sorted numbers. The goal here is to write a program which checks whether a given series of numbers are sorted or not, are arranged in non-decreasing order or not. So we read three numbers and we print ascending if the numbers are in ascending order. We print descending if the numbers are in descending order, and not sorted in any other case. So 1, 2, 3 is ascending and 3, 1, 2 is not sorted. 1, 1, 2 is also ascending. This is because it's not well explained here that 1, 1, 2 is still ascending. So I believe that if we have A less than or equal B less than or equal C, this means that the sequence A, B, C is ascending. Okay, so that's all. We read three numbers and we do this. Oh, we already have this. I will copy paste this class, Control C, Control V. It will be called ascending numbers or sorted. Check for sorted numbers. This looks better. And I will take the first part here where I read these three numbers. So what I can do, I can check whether if num1 is less than or equal to num2, and in the same time num2 is less than or equal to num3. In math we can write like this, but in Java we can't, so we should do this, which is exactly the same. In this case I will write ascending. So for example, I have here 5, I have something bigger or equal than 5, for example again 5, and here I have 7, it's ascending. It is descending if I have num1 bigger than num2 and num2 bigger than num3. In fact, it might be ascending and descending in the same time if the values are 1, 1, 1, for example. But I assume that we should define this better. Strongly ascending or non-descending, right? And else, finally, I'll print not sorted. It depends on the definition whether it allows equality or not. I will consider the numbers are ascending if they are strongly ascending. For example, 5, 10, 20. 5, 5, 10, it's not sorted. But it's a matter of interpretation of the problem statement. Let's check whether this works or not. Okay, I'm waiting for the compilations. 10, 20, 30, it's ascending. If we have 30, 20, 1.5, it's descending. If we have 20, 30, 5, it's not sorted. Looks correct, so let's see the original solution we had. Oh, it's exactly the same, and it is strongly with this strongly ascending and strongly descending problem definition. Okay, we're done with this problem, so we can go ahead with the next one. The next one is called vacation expenses. It's about writing a program which calculates a vacation expenses. It reads season, accommodation type, and count of days, and prints the total expenses based on this table below. So, for example, if we have summer and we have camping, the rate per day is this 30. We don't have this count, so we have the count of days, for example 5 days, multiplied by 30, it would be 150. But if we have, for example, autumn and hotel, okay, the season is autumn, the accommodation type is hotel, the rate is 20, but we have 30% discount, so the rate is 20 by 0.7. Do you agree? It is 1.0 minus 30%. It's 70% of this 20 multiplied by the number of days. For example, it might be 5. So this is how this works. We don't have example here. Oh, it's a big mistake in this problem, but we should format the output up to 2 digits after the decimal point. Okay, so let's see here, vacation expenses. Okay, new Java class, vacation expenses. Again, I will need the main method, I will need the control tab, this scanner, control tab, control V, enter. Okay, and once I have the scanner, I can read from it the input. The input is the season string. Season equals to scanner dot next line. The next thing I read is the accommodation. It's with double M. And then I read the number of days. It would be int dot next int. It's days. So now I'll do something like, if the season is spring, it's better to have this dot to lowercase in order to be able to handle uppercase and lowercase. So I'll have now spring with small letters, and spring with capitals will also work. Okay, so if the season is spring, what we shall do? The season is spring. So if the hotel, if it is hotel, if accommodation is hotel, then maybe I will need a rate. In this case, the rate will be what? I have spring hotel 30, but with the 20% discount, 30 multiplied by 0.8. Otherwise, if it is camping, the rate will be 10 with the discount. This is for spring. In the same manner, we can handle with else if summer. Okay. In the summer, hotel 50, 30 without discount. It's 50 and 30 without any discount. Okay. Autumn, I can handle in the similar way. Autumn hotel 20, 15 and 30 discount. 30 discount means 0.7, 20, 15. 20, 15 with 30% discount. Finally, if it is winter, 40, 10. It's 40 with 10% discount. It's something quite good. This, and 10 with 10% discount is this number. I may have this. And now I can print the rate, the double what I should expenses. I should calculate the expenses, their rate multiplied by the days, the number of days, and I need to print formatted with the second digits after the decimal point. So I need to print F, the percent to F, this with new line, this expenses. I can say something like, and let me check whether this works, because it's not very. This may be done with switch. Okay, I agree, but I don't like it. So let's run this, and we shall enter this. What will happen if we are in the spring at hotel for 7 days? 168 spring hotel. Spring hotel is 30. I'll run the calculator. So spring hotel is 30 multiplied by 7 days is this, but we have 20% discount, so by 0.8 it's 168.00. Works correct. Again, if we are, for example, autumn 15 days for 3 days, autumn at, sorry, I'll need to stop and restart. Autumn at camping for 3 days. Autumn camping for 3 days is 45 multiplied by 0. With 30%, it's 31.50. Looks like it's correct. The logic is correct. If I have mistake here at some of the numbers, okay, forgive me. But the logic here is correct, and it's a good example of nested ifs. 4 nested if statements, which handle these 4 basic cases and 4 inner cases, subcases. Okay, this is the solution I had in mind before the start of this lesson. I read the season, I read the accommodation, I read the number of days, and later, if it is spring, I check for hotel and calculate the total price, like this, days multiplied by the rate by discount. And later, if it is camping, I do similar calculation. I do the same for summer, for autumn, and for winter. And finally, I print the total price formatted as it is expected by the problem statement. Okay, let's go ahead with the next problem. It's called cinema. It's about calculating the price for all tickets for a cinema movie. The program should read the type of the movie, the rows, and the seats per row in the cinema, and it should calculate all the price for all tickets. If all tickets are sold, what will be the price? So depending on the type of the ticket, the type of the projection of the entire movie, we have different prices. Premiere 12, normal 7.5, and discount tickets are 5. So this is price for one seat. So if you have normal 12 rows and 9 seats per row, we have this. We have to normal 7.5, see 7.5 multiplied by 12 multiplied by 9 multiplied by 12 multiplied by 9, it is 810.00, and the output should be formatted with 2 digits after the decimal point. So this is very similar, so I'll copy vacation expenses and this will be called cinema. So I read the type rows and seats per row. I read type rows integer.parseInt of scanner next line and seats per row. And if the type, I'll have to lowercase here, and if the projection is normal, okay, price per seat will be 7.50. So I'll have something like double price per seat or ticket price. Ticket price looks better. Ticket price will be 7.5 for normal, else for Premier it's 12.00, and otherwise it's normal, and the ticket price will be, no, it's discounted, it will be 5. Okay, so I have the ticket price, and if I have the ticket price, I can calculate the total price, which will be the ticket price multiplied by the number of rows multiplied by the seats per row. Again, by design we want to calculate how many, if all the tickets are sold, what will be the incomes. It will be something like total incomes are these incomes. Let's check whether this works correctly. This is the entire solution. I'm not sure whether this will work correctly, but let's see. Normal 12.9, normal 12.9, 810.00. Ah, looks correct. And Premier 2030, 7,200. Looks correct, so we can go ahead. This is the solution I had in mind. I read the input data, I calculate the number of seats, and if the type is Premier, I print the seats multiplied by 10 and format it correctly. Again, if it is normal, I will print the seats multiplied by other price, and I just have to check these 3 cases: Premier, normal, and discounted ticket, and to multiply by different number, which is the ticket price. So we are ready with the cinema problem, and we can go ahead with the number operations problem, which is about writing a problem to evaluate operations, which reads 2 real number and math operator from the console. Math operators are plus, minus, multiplication, division, and percent, which is the remainder of division. And to apply this operator with the given numbers. This is the example, works, explains the problem better. So if we have 10, 12, and plus, we need to calculate 10 plus 12. If we have 10, 12 and percent, we need to calculate 10%, 12. And this is the output. The first number goes here, the second number goes here, and the third number, and the result of first operator second goes here. Number 1 operator number 2 equals to the result, where the result is this, the operator this. Okay, so how to run this? We can just read the input and check if the operator is plus, sum the numbers. If the operator is minus, calculate the subtraction. If the operator is plus, is multiplication, is the star, multiply, etc, etc, etc. So let's go ahead to solve this problem. It's called number operations. Operations looks correct. So I'll have the main method here. Main method. I'll have the scanner here. Control C, Control V. I pressed Control Tab to go to the next window, or the previous window. Control Tab and Control Tab back. I copy this line. Control C, Control Tab, Control V, and this is how I have the scanner in less time. Okay, so next I'll read the first number. Double num1 equals to scanner dot next double. Then I read the num2, and then I'll read, okay, n1 operator n2. I need to read here the operator scanner dot. By the way, I have a mistake here, but I will explain this later. This will not work. Think why? But let's do something like if operator is plus, then print what we need, n1% s, for example, %s, the operator %s equals %s, or this will work correctly. It's not explained at which format we should do this, so we can just do this, or maybe %f will work better. I'm not sure, but this should be num1, num2, num1 plus num2. Print f /n. I'm not sure about this, so I will run the program when still it is unfinished to check whether it works correctly. Okay, so I run number1 5 operator plus. Oh, I have exception. It's hard to understand what's here, but the problem is that if we read next double, this next line will no longer work. So we should use next one and double dot parse. Sorry. So be careful when you mix reading numbers and reading strings. If you read strings, later you can read numbers. But if you read numbers, later you can't read strings. So you should either read only strings or do something else, but in this case it's just the easier way is to read the first one, read the second one, read the third one, and parse this to double, parse this to string, parse this to double. Let's try again and see what happens. Okay, so if we have 5 plus 10, wow, 5 plus 10 is 15. No, 5 operator num2, 5 plus 10 equals 15. Let's try again. I fixed the bug. Okay, this problem looks a little bit more complex. 5 plus 10 is... oh, it's not 40 point, it's string here. This operator plus cannot be floating point. Let's try again. 5 plus 10 equals 15. Oh, percent s looks better. Let me try, because this adds some decimal part. Okay, let's try again. 5 plus 10 is 15. This is how this works. Because the floating point numbers are always printed like this with 0.0. This is how this works. If we want to achieve 10 plus 12 is 22, we should format the output without this 0.0, which should be %.0f. It should be something like this. 5 plus 10 is 15. But if this is 5.5 plus 10, it's 6. So it's better to leave this %s and just to have 0.0, which is not a problem. 5 plus 10 is 15. Okay, we managed to put this correctly, so I can check for minus, and this will be minus here. Plus minus, multiplication, the star will be multiplication. I have also division, and I have also percentage. And let's run this. 5 divided by 2, %2 is 1. Okay, but 5 divided by 2 is 2.5. And 5 multiplied by 10 is 50. Looks correctly, so I assume we are done with this problem. And it's not very short, but that's life. So let's go ahead with the solution I had in mind before the start of the... oh, but the operation is last. 10, 12, 10 plus is last. Okay, we can change the order. Here, if we have plus, we calculate the result. If we have minus, we calculate the result, etc. And finally, we print number 1, operation, number 2, result. This looks even better. Yeah, this looks better because we have only one plus. Let me try. Double result is 0. Result equals to num1 plus num2. Otherwise, result is num1 minus num2. Here I have result equals to num1 multiplied by num2. Here I have the result as num1 divided by num2. And finally here I have result equals to num1 percent num2 result, and after that I print the result. Looks better, more clean code, like 5 multiplied by 12 is 60. Looks correct. So let's go ahead with the next problem. The next problem is called ATM, Automated Teller Machine, or the cash machine on the streets. It's about writing a problem which simulates an ATM withdrawal. So we have balance, withdraw request, and limit. For example, we may have balance of $500, we may want to withdraw $50, and we have limit of $100 per day, for example, or per operation. And we print the withdrawal was successful if the balance is enough and the withdrawal is within the limits. We print the daily limit was exceeded if the limit is exceeded, and we print insufficient availability if the balance isn't enough. Exactly in this order, because sometimes we might have several errors in the same time. Because yeah, but we should print one of these three messages. First we check this. If it is not, we check this. If it is not, we check this. This should not be daily limit, this should be just limit. But this is an example. We have 420 balance, with withdrawal trade $20, we have limit 25. The withdrawal is less than the limit, everything is successful. We have 10 balance, we have $50 requested and limit 20. So the limit is less than the requested, and also the availability is also not enough. But we print only the first error message, and later we print the others. So if we have multiple errors, we print only one error message. This is by design the problem statement. So I'll create a class called ATM with the main method main. I'll press Ctrl Tab to go at this the previous problem solution. I'll press Ctrl C, copy, Ctrl Tab to go back, Ctrl V, which is paste, copy paste. Okay, so I have the scanner. I don't like to write it, it will take more time. So now I will need to read the input data, balance, withdraw, limit. So I have double balance equals to scanner dot next double. I'll copy this 3 times. Balance, withdraw, complex word, and limit. So the first case, if I have enough balance, balance is bigger or than the withdrawal amount. I have enough balance and the withdrawal request is less than or equal by the limit. In this case, everything is okay, and I will print the withdrawal was successful. This message. Otherwise, if I will check for the limit. If the limit is, if the withdrawer is bigger than the limit, I will print this. I try to withdraw more money than the limit. This is. And finally, if it happens that insufficient availability, if I try to withdraw more money than the availability, than the balance, S out, okay, this is insufficient availability. Let's try to check whether this works correctly. 420, Control V, it doesn't work. I'll try to copy this, to run this, and paste. Oh, it's pause, it's not paste. Control V. Withdrawal is successful. Okay. 10, 50, 20, Control V. Limit was exceeded. And if I have 500 and I want to withdraw 600 and I have very big limit, the availability will not be sufficient. So this is the entire problem solution, and we can go ahead with the solution I had in mind, which should be very similar. Read the number, check whether the balance is enough and the limit is okay, and we print the withdrawal was successful. If the limit is reached, we print the limit was exceeded. It's not daily. I changed this because it's not correct to be daily. It's a per operation limit. Sorry. And finally, insufficient. Yes, because in all other cases it will be, we should fall in one of these three cases. Either we have successful withdrawal, or we have limit exceeded, or we have insufficient availability. Yes, we don't need to put this, but it's better to have it. The code will be more readable. So we are done with this ATM solution, and we have our next problem to be solved. It's about writing a problem to find the biggest among 5 numbers. We have 5 numbers, 5 integers, and print the biggest of them. Here it's 5, here it's -1. Okay, so let's solve this problem. It's called biggest of 5 numbers. We go here, we increase the font with Control and the mouse wheel. I print main method. I press Control Tab to copy this. Control C, Control Tab, Control V, Enter. And now I read the first number, int num1 equals to scanner dot next int. Okay, and I copy this 5 times. 1, 2, 3, 4, 5. And now, when number 1 is the biggest, if number 1 is bigger by the number 2 and is bigger than the number 3, and num1 is bigger than num4, and num1 is bigger by num5. In this case, okay, the biggest, what I should print? I should print just the number. The biggest number is num1. Do you agree? Num1 is bigger by num2, by this, bigger than this, bigger than this, bigger than this. So it's bigger by all of the others. I print it. But it should be bigger or equal, because if it's equal to some of the others, it's still the biggest, right? If we have, for example, here 5, 5, 3, 5, 3, we agree that num1 is the biggest, and it's equal to this one. Okay. Otherwise, I'll have another check to check whether number 2 is bigger than number 1, 3, 4, and 5. Maybe I need to reduce the font. This is number 2 is bigger than 1, 3, 4, 5. Then number 3. It should be bigger than num1, num2, 4, and 5. Num3 is bigger than 1, 2, 4, and 5. The same for number 4, sorry. 4 with 3 and 4 with 5. So number 4 is bigger than 1 by 2, by 3, and by 5. It should not be bigger than itself. And in all other cases, it should be number 5. Because if we have 5 numbers, definitely one of them is the biggest. Or we may have several biggest ones, but one of them will be bigger or equal than the others. So if it is not this, 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 it should be this. Right? Let's see whether this works or not. So I have, for example, 10, 1000, 20, 30, 40. It's 1000. If I have 5000, 1, 2, 3, 4, it's this. If I have 3, 4, 1000, 5, 6, it's 1000. The third, 1, 2, 3, 1000 is the fourth. Works correctly. I have 3, 4, and 1000. So I matched the five cases. I had the first biggest, I had the second number to be the biggest, I had a test where the third was biggest, the fourth, and now in this test the last one is the biggest. I can try with negative numbers, minus 10, minus 25, minus 15, minus 30, minus 5. Minus 5 is the biggest. Looks correct, so this is my solution and it's correct. Let's see what I had in mind before the start of this lesson. It was very similar. If number 1 is bigger than all the others, so it's bigger than num2, in the same time bigger than num3, in the same time bigger than num4, and in the same time bigger than num5, it's the biggest. In the same time, else if, check the same for num2, check the same for num3, check the same for num4, and otherwise num5 is biggest. I already demonstrated this to you, so we are done with this problem, and I'm happy that this was the last problem in these exercises. And in summary, we demonstrated and explained that an if-else statements can be nested within another if-else statements, which is natural. If we have if-else is a statement, it can be put everywhere where a statement can be put. Everywhere where we can put system out println something, we can put if-else. If in the else statement we put another if-else, it's a statement, we can do it. So we can nest statement if-else inside another if-else. So we can have if-else, if-else, if-else sequence, and in some of these cases we may have other if-else, if-else, if-else sequence, like we already demonstrated. Combined with the and, or, and not, and brackets, with these logical operators, we can achieve more complex conditional statements, and we can check whether num1 is bigger than several other values with the AND, or we can construct more complex expressions. Together with the nested ifs, we can check almost everything. And the switch case statement, it's alternative to the if-else, where we have a single expression and we check it for many values. It's very useful with multiple labels, where we can check for many values and do the same thing to avoid something or something or something or something. So in summary, we already have the knowledge and skills about building complex programming logic, branching logic, which does different things depending on the different input by checking with logical operators and with more complex conditional statements. Now we have good knowledge and skills about using conditional statements in Java. In the next lesson, I will show you how to repeat pieces of code using loops, and this will be our next level of advancement in the coding skills. Did you like this code lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free videos, tutorials on computer programming, Java, software engineering, and many others. Get free access to the practical coding exercises and the automated judge system for these code lessons to evaluate your code from the exercises you write. Get help from the mentors and meet other learners. We will answer your questions. And it's all free, completely free. So join now.